So we'll start the recording so that anyone who maybe can't join us right now can watch later. Welcome everyone. Thank you for joining us this evening. I'm Hunter Klingensmith. I'm the Visitor Experience and Exhibit Manager here at the Swaner Preserve and EcoCenter. We're so happy to have you here to hear from Marshall all about the Beaver Dam Analogs and all of the projects that he's been doing on the preserve. I'm joined tonight by Marshall Wolf, who is a PhD candidate in the Watershed Sciences Department at USU, Ria Cone, who is our Conservation Coordinator, here at the Swaner Preserve and EcoCenter, and then Michael Christensen from West Valley Arts as well, who is we're partnering with West Valley Arts on presenting this presentation to you. So I'd like to tell you a little bit about why we're doing these presentations. Obviously, Marshall has been doing some work on the preserve, and that's really exciting, and we always love to bring you information about that. But also, this event is presented in conjunction with the traveling exhibition Waterways from the Smithsonian Institution, which is currently on display here at the Swaner EcoCenter. This exhibit explores water and the human connection to water and is part of a larger state initiative called Think Water Utah that is organized by Utah Humanities. This exhibit will be on display here at the Swaner EcoCenter through March 27th, and Michael is going to tell you a little bit about another partner water exhibition that he has on display at his center right now. Before we get started, I would like to thank Utah Humanities and the Smithsonian's Museum on Main Street program for making the Waterways exhibition and Think Water Utah and all of its associated programming possible. I would also like to thank the Summit County RAP Tax, the Utah Division of Arts and Museums, and all of our wonderful supporters for making this and other walks, talks, and workshops at the Swaner Preserve and EcoCenter possible. We are obviously doing this through Zoom webinar, so we can't see all of you. However, if you have questions for Marshall during the talk, you can submit them in the chat or the Q&A function at the bottom of your screen. And then once Marshall is done with his presentation, Ria and I will field those questions to Marshall, and he will answer as many as he can in our allotted time. We really look forward to hearing from you. Also, if you have a question that you don't want to type out, we do have the ability to unmute you. And so you can put that into the chat that you'd like to ask your question verbally, and we can unmute if we need to. And then from there, I'm going to pass it off to Michael to tell you a little bit about West Valley Arts and their programming there.
Is unstable. Anyway, I'm the visual arts manager for West Valley Arts. I want to thank Hunter for partnering with us and the Swaner Preserve for partnering with us on the event, and also thank our guest tonight, Marshall Wolf. Basically, tonight's event is on the West Valley Arts side of things. Is being presented as part of a larger series of programs for an exhibit we're hosting in West Valley at the Utah Cultural Celebration Center through April 19th. It's called H2O Today, which is also a sites exhibit. It's a wonderfully interactive and immersive exhibit with tons of digital media and auxiliary exhibitions that are very Utah specific. If you want more information, go to wvcarts.org and you'll be able to see all of our accompanying programming there. Some of our sponsors that I wanted to thank have been thanked, so thank you. But we will also thank, on our part, Salt Lake County Zoo Arts and Parks Program, West Valley City, West Valley Arts, the National Endowment for the Humanities, and also that we'd like to give a special nod to the Utah State Legislature. Having said all of that, thanks again for letting us partner on this project. I'm really looking forward to what Marshall has to say, and I will introduce Ria Cone, also with Swaner Preserve.
Thanks, Michael and Hunter. I'm Ria Cone. I'm the Conservation Coordinator here at the Swaner Preserve and EcoCenter. We've been working with our presenter tonight, Marshall Wolf, since about 2019, and we're really excited to have him here. I want to mention, if anyone is excited about the work that you see tonight, we rely on volunteers to get a lot of this stuff done, and we're definitely going to have a lot of opportunities this summer to get you out on the preserve. So keep an eye out for that. Hunter will send out some links in the follow-up email, but you can get involved in projects like this. So Marshall's Beaver Ecosystem Ecology project is constructing and monitoring over 15 Beaver Dam analogs on the Swaner Preserve on both Campbell and East Canyon Creeks. And we're excited to share all about beavers, beaver dam analogs, and some of the cool findings from our work thus far. So with that, I'll pass it off to Marshall.
All right, let me just get my slideshow pulled up. Hopefully y'all can see that in full screen mode now. I'm just gonna hide everyone so that I'm not distracted. But yeah, without further ado, I think we'll just go ahead and jump into dive into the world of beaver assisted restoration. Before I get started, I just wanted to give a shout out to everyone who's made this project possible, in particular, the Utah State University Ecology Center, the Wild Utah Project, the Utah Department of Environmental Quality, of course, Swaner Preserve and EcoCenter, and the Department of Watershed Science at USU. So just to kind of outline the talk for you all today, really the purpose is to kind of give you an introduction to why we want to use beaver in restoration anyway, kind of introduce the idea and the concepts behind the Beaver Dam Analog, which I'll be referring to as BDAs, so I don't have to say Beaver Dam Analog 100 times. So just to introduce the Swaner portion of the BDA project to you, and then to demonstrate how we're going to monitor and quantify how successful this restoration is and provide some preliminary results. Graphically speaking, what we're looking to do is move from the image on the left side of this figure to the right, generally move from a single threaded incised channel to a multi-threaded, more dynamic channel that provides more ecosystem services. So let's just jump into why beaver anyway. So beaver are kind of the quintessential keystone species. The reason for that is they actually build dams and modify the habitat around them, which forces water to overflow their dam, to pond up behind their dam, to enter the subsurface flow paths, and then to kind of leave a single-threaded, single-channeled state and enter a more multi-threaded, multi-channel state. This has kind of cascading effects across a multitude of different species, everywhere from tiny little insects and frogs to moose and waterfowl that migrate hundreds, if not thousands of miles. In addition to the ecological and biological components, Beaver Dam actually changed the physical, structure of streams by adding their dams. Well, what they do is they actually influence or kind of guide the stream to migrate, create new meanders, and then to create different patterns of deposition and erosion, which lead to complexity in the streams themselves. Over time, as beaver kind of aggrade sediments behind their dams, what they can actually do is raise the level of the stream itself and the water table, which subsequently leads to multi-threaded and more dynamic channel experience than was there prior to them coming in. So the origins of beaver restoration really kind of start in the early 1900s. Enos A. Mills published his book In a Beaver World, which was really just kind of a collection of his observations. He spent over 50 years being a naturalist and guide in what became Rocky Mountain National Park. And his book, published in 1913, was really just the first collection of information set out to the world about how beaver influence other species. In the late 1940s and the early 50s, actually the states of California, Oregon, Idaho, and even Washington actually parachuted beaver into wilderness areas using old parachutes from World War II. They would take beaver from kind of nuisance beaver from the developing suburbs and agricultural areas and actually load them up into airplanes and launch them into prime habitat in the Forest Service lands. And then in 1959, Eric Collier, he published a book, Three Against the Wilderness. And this was really important because in his book, he actually describes what is kind of the first recorded instance of humans building fake beaver dams. He was a trapper up in British Columbia, and he actually restored blown out beaver dams and built his own in order to provide more fur-bearing animals so that he could continue to live his subsistence lifestyle. That kind of brought us all the way up to modern day mimicking of beaver, which was kind of pioneered in 2010. in Bridge Creek, which is a tributary to the John Day River in Oregon. And you can see an example of one of these Beaver Dam analogs there on the right. So John Day had a population of beaver, but their dams kept getting blown out because the stream had incised. And so stream power, essentially the force that the stream could exert upon a beaver dam, was increased. And so these dams were very, very short-lived, like oftentimes 2 months at the most. So some researchers at Utah State University and NOAA, along with the Oregon Department of Fish and Wildlife, kind of pioneered this concept of building what we now call Beaver Dam analogs. Just to give you an idea of what that entails, here's a short video. Essentially, the process is to use a hydraulic post pounder or a gas-powered one to pound in wooden untreated fence posts anywhere from 2 to 3, maybe sometimes even 4 feet deep into the stream. At that point, we kind of line the backside of the dam with rocks and stones to give it some structural support, and then take a boatload of willows and interweave them between the posts, both facing parallel to the flow and perpendicular to the flow to really raise the height of the water. And finally, we throw in a bunch of fine sediment like silts and sands to really seal it in like a natural beaver would. So with the kind of increase in understanding and knowledge of what beaver do to help ecosystems, there's kind of been a growing effort in the last 20 years to really study beaver restoration itself and figure out, is restoring beaver the same as just having beaver there originally? Kind of the first landmark study in the recent series was actually published by McKinstry and Anderson in 2002. And what they did is they relocated over 100 nuisance beaver in the state of Wyoming to places where they would cause less problems with farming and irrigation, but could still live a good lifestyle. Plenty of food, plenty of water, etc. And what they found is very, very rarely did beaver actually stay where they got dropped off. Most of the times they were in the area where they were left for less than 100 days before they swam downstream and were lost contact with or were eaten by some sort of predator. More recently, research has actually started to focus on beaver dam analogs themselves, trying to figure out if they behave the same way that natural beaver dams do. So this was a study by Weaver et al. In 2017, and what they were actually looking at was if the temperature of streams that were unimpounded were different than the temperature of the stream that was impounded by beaver dam analogs and natural beaver dams. So all these little red dots were actually temperature loggers that they put in the stream, and the purple dots are the dams themselves. And if you look down at the bottom section down here, what you can actually see is the unimpounded reach, the reach without any beaver dams. The temperature throughout the reach was identical, within ½ degree at any given moment. Whereas in the beaver impacted reach, you have all these different temperature loci or microhabitats, really, where different species and different life stages of each species can kind of optimize their temperature in order to ensure optimal growth and reproductive success. Most recently in 2020, just published this last year, there was a study that also came out of Wyoming dealing exclusively with beaver dam analogs, which was pretty cool. They were really interested in how BDAs were influencing the processing of nutrients within the stream. And so they actually measured a bunch of pore water and surface water and built some maps of how BDAs were influencing the dominant type of water within each reach. What they found was that this dam C down here was actually behaving almost exactly like a beaver dam in the adjoining reach. So they really found that BDAs can cause effects that are very, very similar, if not identical, to natural beaver dams. So with that as a background, I'd like to just transition into giving you all a little history of, I guess, Swaner Preserve and Snyderville Basin as a whole. So when I say Snyderville Basin, really I'm talking about the headwaters of East Canyon and Silver Creeks, centered on that yellow or gold star, which is Swaner Preserve. So it's very likely that mountain men did trapping throughout Snyderville Basin in the 1820s and 1830s. And the reason I say it's very likely is because two of the first 10 or so Rocky Mountain rendezvous, which were set up by the Rocky Mountain Fur Company to trade and sell beaver pelts, happened actually within 100 or 150 miles of Snyderville Basin. The first one being in Cove in Cache Valley. There was two over at Sweet Lake, which is what we call Bear Lake nowadays, and then one in Hams Fork in Wyoming and one in Burnt Fork in Wyoming. So they were very close and likely trapping these same areas. By the mid 1840s, the first homesteading and agricultural activity happens in Snyderville Basin with the coming of the Mormon immigrants. And then in 1853, we have really the first record of sure alteration of the stream system by human influence with the building of Snyder's Mill. To provide some more evidence of this, I have this 1869 map from the General Land Survey Office that I found. To orient you a little bit, this big field out here is what is the modern day field of Swaner Preserve. We have I-80 kind of rolling through here. This is the highway to Heber City running down here. And then this is where SR 224 runs down to Park City. I'd like to draw your attention to two areas. Right here on Campbell Creek, what we now call Campbell Creek, there is a very, very large and long side channel. And then here on Silver Creek, we have a series of antibranching channels, secondary and tertiary channels. So this just illustrates that the restoration potential of this area is there, and that historically we did have a more antibranching dynamic system with multiple channels than currently exists today. To kind of show this point a little clearer with some more modern maps, I picked out a spot along the preserve illustrated by that gold star. It's actually the most downstream segment of Swaner Preserve. And this is 1952 aerial imagery. You can see we have a meandering stream with lots of these kind of light gray blotches on either bank, which are little patches of willows. We move forward about 10 years to 1962, we can see very similar things are going on, patches of willows, meandering stream. However, if we hop forward 30 years, you can see there's been some pretty dramatic changes. I-80 has been built, we have a frontage road running up and down now. The stream has been artificially straightened through this whole reach. And we have a pretty dramatic loss of willow cover throughout the reach, which is going to impact riparian shading and the like. 2019, similar story going on, straightened stream with much less willow that existed 70 years prior. So really that brings us to some of the challenge of East Canyon Creek. In 2002 and again in 2010, the state of Utah listed East Canyon Creek as an impaired stream under their total maximum daily load framework, or TMDL. Really what that says is that there was a number of problems wrong with the stream, and it illustrated how you could go about trying to fix those. So I'll just kind of run through that here. The biggest problem that it illustrated was that there's high nutrient loads, particularly nitrogen and phosphorus. In addition to that, there's little riparian shading, which created a feedback loop where there's lots of light going into the water column and lots of nutrients. So we have an explosion of macrophytic and algal growth within the water column, which then leads to lots of respiration at night in particular, which drops dissolved oxygen and can be very harmful for native species like Bonnyville cutthroat trout and other native aquatic species. In addition to that, it illustrated that there is simplified stream habitat, i.e. not a lot of side channels, backwaters, and stream migration, and lack of floodplain connectivity. Both of these fed back to further decrease the likelihood of establishing riparian vegetation like willows or cottonwoods, which might shade the stream and reduce macrophytic growths. So how do we fix that? The best way really to go about doing that was actually put forth in 2010 by Beachy et al. They called it process-based restoration. The general idea behind this is that you have symptoms that you're trying to heal with your restoration, if you will. And so how do you heal those? Well, the best way to heal them is to actually go back and figure out what processes are causing these symptoms. So that's why we can see the processes and the symptoms are linked here. And then go ahead and tailor the restoration activities that you're proposing to the local sites, i.e. make sure that you can actually change those processes at the local sites. And then define some explicit measures of success. So you know, have I accomplished what I'm looking for? So what does that look like for our system here at Swaner and Snyderville Basin? Well, we have a problem of too much nitrogen, lots of macrophytic growth, which is leading us towards very low concentrations of dissolved oxygen, particularly in the summer. And we're seeing increases in brown trout, which correspond to losses of our native Bonneville trout. I think that these symptoms are directly linked to the process of channel evolution and channel migration, which vicariously influences the establishment of woody riparian plants that could help shade the channel and extract nutrients from the stream. In a place like Swaner and Snyderville Basin, it's a very depositional environment, meaning low gradient streams. So there's not a lot of wood coming in or landslides or anything like that that might cause stream migration or stream change. So this is really an ideal spot to introduce beaver and beaver-like structures. And then we define explicit measures for our success, and I'll go into that a little bit later, but generally that's done in what's called an adaptive management framework, meaning you can go back and change things if they aren't turning out exactly how you'd like them to. So to show you just what that kind of looks like on the preserve with some Beaver Dam analogs, here's a photo of a BDA built in about 2015 on Swaner Preserve. And you can see it's already started introducing some processes that we're talking about. It's blown out, which some people might say is a failure, but actually in this case, it's doing exactly what we want because it's taking this artificially straightened stream and it's giving it some more meandering. It's adding in a point bar made of gravel over here. The whole game here is that most of Swaner is in the stage A or stage B right now. And what we're looking to do is get it more down to a stage E or a stage F, because stage E and F provide more ecosystem services that humans depend on, like water filtration and perennial flow throughout the summer months, while also providing more habitat for a variety of species, including native species of concern. So in order to accomplish that, we're going to go ahead and build like a beaver, build some BDAs. These are just some actual photos of BDAs we built this summer on the right, showing you kind of what they look like, and hopefully they look almost like a real beaver dam to you, and then a conceptual model of how you might go about building one. So with that, I think I'm just going to transition and give you all an overview of the BDA project itself. So really the goals of this project, like I've been harping on a little bit, is to diversify the fluvial processes. And when I say that, I mean, create more overland flow events, create channel migration events, create secondary and tertiary channels, kind of like you can see in this photo on the right. In addition to that, we'd like to enhance habitat for native species, particularly by increasing late season stream flow, decreasing the water temperature variance. So when I say that, I mean decrease the temperature in the summer, keep water cooler in the summer, but warmer in the winter, so that we kind of stabilize the temperature on a yearly and daily basis. And then increase nighttime dissolved oxygen so that we can make these stream segments more habitable to Bonneville cutthroat trout. In order to top that off, we'd really like to recruit some riparian vegetation, particularly willows and cottonwoods. As you can see from this photo, a lot of the willow stands that are currently present in this reach are actually not on the stream itself, so they're not actually shading the stream. And then promote colonization of the main stem habitat of East Canyon Creek and Campbell Creek itself by beaver, so that we don't have to continue to maintain these structures ad nauseum. Our restoration plan was really three-pronged. First was to reinforce the existing BDAs built in 2016 and 2015. Those are the orange dots on the downstream segment of the preserve over here. We built 2 new heavily monitored complexes with 5 to 6 beaver dams each. Those are the little pink circles with black fill up here. And then to kind of link our restoration efforts to enhance the impacts past just the reach scale. We really like to see basin-wide impacts of this. So seeing dissolved oxygen concentrations being exported downstream, seeing Bonneville cutthroat returning to more than just 1 or 2 sites would be the optimal. Actually, I'll talk about it here in a little, but Swaner and Wild Utah just received a grant from the Park City Climate Fund to install 100 BDAs on Snyderville Basin over the next 2 summers. So what does this all look like? Well, with reinforcing the existing, this is the photo I showed you earlier of what I said was good process on a Beaver Dam analog. So what we did this summer is we actually went in and installed 6 new dams, both above and below that existing dam, to keep aggrading the channel there and to really maintain that meander that's occurring. And actually, if you pay close attention, there's a little willow right here that actually is not in this photo here. So we've already established at least one willow that someday maybe will grow big and propagate itself multiple times across the bend and help shade out that area. For our heavily monitored sites that I mentioned, we have 2 of the freshly built BDA complexes. Those are here in red. And they have upstream control reaches in turquoise, 2 of those as well. And then we have what I call a positive control, which is a natural beaver dam complex that we can compare to the fake ones to see how close are we getting to the processes that are actually going on when real beaver build these, and an upstream control reach of that. So 6 of these heavily monitored sites in total. At these sites, we're doing fish community surveys where once in the late spring and once in the early fall, we go out and we collect all the fish that we possibly can using electrofishing techniques. We're doing some riparian ecosystem monitoring. We have groundwater wells, we have temperature loggers for the water, and dissolved oxygen loggers that we just installed this year. In addition to that, we're doing some drone imagery and sub-meter GPS surveys so that we can quantify how the stream bed and the actual floodplain itself are changing. To give you an idea of what that looks like, here's kind of a map of one of our sites before BDAs were installed. The background coloration and structure that you see is actually from a drone image. And then the contour lines themselves are from the GPS survey. So the GPS survey allows us to pull out big pools like this one with more riffle sequences like this one, while the drone survey allows us to actually pull out changes to willow patches and vegetative characteristics. In addition to that, we are going to be measuring some tree growth with tree rings in the future, and we are measuring Ndvi, which is normalized difference in vegetation indices. I'll talk a little more about that later. And then each fall, we do beaver occupancy surveys where we walk the BDA complexes and try and see if beaver have moved in yet. And then scaling up. So as I mentioned before, Wild Utah and Swaner Preserve just got a grant from the Park City Climate Fund to install 100 new BDAs across the Snyderville Basin area by 2022. Other groups are working to restore the Bad Apple Trailhead with Beaver Dam Analogs and wood jams, and Toll Creek Canyon already has some BDAs installed. So really the next steps are to go ahead and find some private landowners who'd be interested in linking restoration sites between places where we already have projects on public land through private land. So if you know anyone who might be interested, please reach out to Ria or Hunter, and hopefully we can collaborate. With that, I think we'll just jump into some results. I'm sure you all are excited to see what's happening. Mostly, I'm going to focus on these 4 areas right here. That is the new BDAs that we built in 2019 and their control sites, just because I think they're the most interesting for everyone and in the name of time. Before we actually go and look at graphs or anything like that, I thought I'd just show you a video. This was taken about the same time last year. This is along East Canyon Creek. We installed about 5 BDAs here. And you can see right away how much overland out of channel flow is happening, secondary channels, tons of backed up and stored water because of these 5 BDAs that we built. At a higher elevation flight, you can really see these side channels well. And pay attention to as we transition out of the Beaver Dam complex into a non-modified system, how much different it looks. Pretty cool, pretty impressive. Lots of flooding brought about by just 5 little BDAs that we built. I guess they're not that little, they're pretty big, but. So I'll just jump into this. Actually, this is the same complex that we just flew over. For all of these images that I'll be showing you in this part, the direction of flow is from the bottom of the screen to the top, and I've denoted that with a couple little arrows so you don't forget. But essentially, we have a BDA. We have 4 BDAs in this photo. There's one here, one here, one here, and one here. Both these images were taken at the same time of year, just 1 year apart. And so you can see immediately in the 2020 imagery that we're ponding tons more water, especially in the kind of edges of these bends here, here, and here. We're really getting water up and onto the floodplain, which is fantastic because that allows it to slowly percolate through the floodplain soils and prolongs the base flow, which is what everyone's looking for. Another big thing that jumps out at you right away is how much brown area of like super brown kind of dead vegetation, bare soil that's going on in the 2019 imagery versus the 2020 imagery. You can see that most of that has actually been filled in by native rushes and sedges, which is awesome. And it's kind of an immediate indicator of an elevated an elevated water table. We have similar things going on at the Campbell Creek site. You can see again, 1, 2, 3, 4 BDAs in this photo. You can see that there's a pretty dramatic increase actually in water being stored. If you compare this pool here to this pool here, there's a lot more water in the 2020 imagery. Contrary to the East Canyon Creek site, you can actually see that at the Campbell Creek site, there's more brown, empty, unvegetated areas in 2020 rather than 2019. And the reasoning behind that is this dam, for most of the winter and spring of 2020, was actually forcing water in overland flow in a couple small side channels out of the stream and onto the floodplain. So these are new sediment deposits. Same thing was happening here with this dam. Water was being forced out of the stream and onto the floodplain to form new sediment deposits, which is fantastic because those are actually the favored surfaces for cottonwoods and willows to establish from seed, is on bare mineral sediment deposits. So we're looking to create more of those, but preferably a little closer to the floodplain so that we'll be more successful at recruiting cottonwoods and willows. We also installed some dissolved oxygen loggers to the stream, as I mentioned before. These are kind of what they look like. And these little orange dashes are actually the locations of the Beaver Dam analogs. And these little turquoise dots, like I've highlighted out here, are actually the location of the dissolved oxygen loggers. So we had 6 of them installed at the Campbell Creek site. I've color-coded a few of them for you, just so you can keep track of where they are spatially when I show you the data on the graph. So here's the graph that I was mentioning. You can see F is the most upstream one that's plotted in the forefront. This red line actually is 7.5 milligrams per liter of dissolved oxygen, and that's what is widely accepted as the minimum needed for a healthy cutthroat trout population. So with that in mind, we can see that even our inflowing control reach isn't quite at 7.5, particularly at the night. These up and down cycles you can see are actually on the daily scale. So this is happening at a daily basis. So you can see that even the yellow one is not quite where it needs to be to support cutthroat trout. In the middle of the complex, this C logger is having very wild swings, all the way from 30 milligrams per liter all the way down to 5 milligrams per liter in a single day. And that's because we're ponding water, right? And so we're having a tremendous amount of algal and macrophytic growth. But interestingly enough, if we look at the A, what is being exported from this BDA complex itself, it very well tracks F and is actually above F, particularly at the end of the growing season here in October. So just to give you a little more insight, I've plotted those right next to each other without the distraction of C. And we can see that A and F track each other super well throughout the course of the summer. Actually, A even is less variable than F for a good portion of time. But here in October, something changes in the system. And I think it is actually, we went back in and we fixed up the dams at the end of September and the beginning of October. And I think that's this change in signal you're seeing here, where we are exporting a lot more dissolved oxygen every day, but we're also losing some more at night during the latter part of the summer and the early fall. To move on, we'll talk a little bit about Ndvi, like I mentioned before. It's a normalized difference in vegetation indices. And it's really a proxy for primary production. It's calculated using red and near infrared bands, as shown in the equation below. And what it really indicates is how green a landscape is. For this study, I've been using Sentinel-2 imagery, which has 10-meter resolution. So it allows us to separate out the floodplain that could be affected by our Beaver Dam analogs from upland features like hill slopes and houses and all that kind of stuff. For all these images I'll be showing you, it's actually an average image. So for the case of this one on the right, it's actually 41 different images averaged over 2020 that were taken between the 1st of May and the 1st of October. What you can see right away is things like the golf course and irrigated alfalfa pop out really well, while things like the highway and buildings that have zero greenness are very well contrasted. So to take a look and see what that looks like at the BDA and control reaches themselves, this is 2019, prior to us installing the BDAs. So these two sites should be expected to be identical. We have the East Canyon Creek treatment reach at the downstream and its control reach. And then we have the Campbell Creek treatment reach where we installed BDAs and its control reach. And you can see that these are almost identical in their levels of greenness, and that they're quite green. They're about 0.6 to 0.5 in the index scale of greenness, which is perfect. That's exactly what we want, to have treatment and controls identical before we do anything to them. In 2020, with the install of the BDAs, we can actually see that there's been a shift in this relationship, where the treatment reaches, the downstream reaches where the BDAs were installed, are now significantly greener than the control reaches, the upstream ones, which is cool. Now we're seeing an actual impact to the vegetation that we've created by installing these 5 BDAs at each site. To dive into that a little bit more, use some data just to prove to you that I'm not just altering pixel values or anything like that. We have a graph of our 4 sites before we installed the BDAs. So the East Canyon site is ECC3 in green. Its control reach is here in orange or yellow. And then we have blue being the Campbell Creek site and red being its control. You can see they track each other really well with only a pretty small separation of about 0.5 from time to time. Now in 2020, after we've installed the BDAs, we can see considerable separation, particularly at the Campbell Creek reach happening over the course of the summer, and then some really nice separation happening at the East Canyon reach at the end of the summer, once things get really hot and dry. So we found quite amount of aquatic biodiversity in our surveys for fish and just trampling around the streams while at Swaner. Found 7 different species of native fish and 2 non-native fish. We found the Pilos Crayfish, which is these 3 different crayfish photos that I have out there, which is actually a super rare find, which is pretty cool. It's the only native crayfish to the Bonneville Basin and thus to Utah. And it's declined dramatically since about the 1950s. We've also found Western pearl shell at a couple sites at Swaner Preserve, which is pretty cool because it's a Utah species of conservation concern. Now the fishermen out there are probably most excited about the fish results, so I'll move and talk a little bit about those now. I'm going to concentrate on the fall electrofishing numbers because we have some migrant fish that move in the spring to spawn in different locations, so it kind of biases the numbers a little bit. For all of these, we conducted 2 passes of electrofishing at each reach. So we went through, caught all the fish, held them in tanks, went through again, caught all the fish, and held them in tanks so that we could really get an idea of how many fish were in each section. In the future, we'll have some pit tag based data, but I don't have it here. But we have caught a couple Bonneville cutthroat trouts, actually mainly at the natural beaver dams, and we've caught this particular trout twice. And to prove that to you, I have 2 photos taken in 2 different years, and if you actually match the spots, like on its gills or just below its pectoral fin over there, you can see that it's the same fish. It's got the same spots. So just to take a look at fish biomass across the sites, we have the East Canyon site and its control reach, Campbell Creek site and its control reach, and the bars are color coded by year. So 2019 in gray and 2020 in black. You can see right away that here at the BDA reach for East Canyon, we've seen a pretty big decrease in biomass overall between the years. And I'll dive into that a little bit more here in a second, but really I think what's happened is we've gone from an adult dominated system to more of a nursery or a juvenile dominated system there with the installation of the BDAs. The difference between the control reach at the East Canyon Creek, it's unfortunately a little erroneous because our BDAs were too successful and we flooded out our original 2019 control reach, so we had to move it upstream a little bit. The Campbell Creek reach, we can actually see that there's a pretty dramatic increase in biomass, and at the Campbell Creek control, we can see the biomass numbers are almost the same. So now I'm going to dive a little more into the specifics of that just to orient you at this slide. We have a row here being the BDA reach and a row being the control reach, or sorry, that's a column. 2 columns, BDA and control, and then a row being the 2019 year and a row being the 2020 year. And these little numbers in black are actually just grams of fish biomass. I've color coded each of the pie sections by species and life stage. So brown being the adult brown trout, orange being the juvenile brown trout, gray being the adult Utah suckers, and teal here being the juvenile Utah suckers. I forgot to mention, for those of you who don't know, this is what a Utah sucker looks like, and this is what a brown trout looks like. So we can see that at the BDA reach in 2019, we had predominantly adult Utah suckers with a small spattering of juvenile fish of each species and a decent amount, almost 5 kilograms or over 5 kilograms of adult brown trout. The 2020, we can see an almost a total change in that, where we are now completely dominated by juvenile Utah suckers, with a pretty big increase actually in juvenile brown trout too, and still a couple adult brown trout hanging out, but the adult suckers have completely left. In the control reach, the one that we had to change, unfortunately, we can see that the ratios actually have changed very little between the years, which is good, even though the biomass changed. Unfortunately, with some of these Utah suckers, they can weigh anywhere from 1.5 to 2 kilograms, so 1 to 2,000 grams. So just catching a couple more Utah suckers can really, really change the amount of biomass found within the stream. When we look at the Campbell Creek site, we see some different patterns. So the same orientation here with treatment on the left, control on the right, and then years in the rows. We can see that at Campbell Creek reach, we've gone from actually only having brown trout to now introducing juvenile Utah suckers. We actually saw adult Utah suckers spawning in between the BDAs during the spring. So we have some proof that there's some new species moving in because of the restoration, which is pretty cool. In terms of absolute amounts, we actually have 7 times more adult brown trout in this reach than we did prior, with over a 10-fold increase in the juveniles brown trout. In the control reach, we can see the ratios are a little different, but overall the breakdown's pretty similar, dominated by adult Utah suckers, with some increases in the amount of juveniles of both species found within the reach. And finally, to beaver occupancy. So as I mentioned before, each fall we walk each of the control reaches, sorry, not the control reaches, the BDA reaches. And oftentimes it looks a little bit like this, a little snowy, a lot of dead vegetation. And we look for surefire signs of beaver occupancy or their intent to overwinter in the area. Essentially what we're looking for is the building of a lodge, a food cache, or evidence of dam maintenance. And all three of those are kind of illustrated by this fun little cartoon down at the bottom. And so what a food cache is actually just a collection of beaver edible sticks that they stab into the substrate of the stream and kind of use the stream as a refrigerator for overwinter. It also serves a secondary purpose of an emergency food store, which is maybe why it's called a cache, because in cold climates like ours, if the water is to completely freeze over, then the beavers are actually stuck in their dam or in the water. So they need to have a food source that they can get, or sorry, in their lodge or in the water. So they need to have a food source that they can get to without leaving or breaking through the ice. So any two of these three, we define that as occupied for the winter. The cool thing is 75% of our BDA reaches have some form of occupancy, or sorry, some form of use. So that is at least one of those three. And one of them was actually taken over by beaver and had all three of those. So to show you that one, it was actually the downstream most of the BDA complexes at Swaner. It's highlighted in orange over there. To just give you an idea of what it looked like. So this is the blown out BDA that I've shown you a couple times. These are two new BDAs upstream that we built this year. So the beaver has been maintaining both of these, and this gold star denotes where they built a lodge and then an accompanying food cache right next to it. I'll just show you a little photo of that. It's a pretty fresh lodge, so it's not that impressive in terms of height or size, but hopefully they keep on working on it for a couple of years and take some of the work out of our hands. So with that, I'd just like to give a special shout out to everyone who helps this year. There's been a ton of people, but in particular, Ria Cone, Nell Larson, Janice Gardner. We have Hunter and Katie and my tech Jaron, good friend Greg, and then Mr. Lemons himself. And then of course, the most important star is Johnny A. Beaver. Who's really the one that is helping us out here. And again, a shout out to the funders for providing us the money to get this research and installation and restoration done. With that, I'd just like to thank you all for coming. Cheers to some beaver beers. And I'd like to take any questions if you have any.
Thanks, Marshall. I have to say that I've been with Swaner for about 6 years, and I've helped with a lot of restoration projects, and none of them have been nearly as exciting to watch as this one. A lot of times it's like you plant the seeds and then you wait a whole lot of years until something grows to see what happens, or it's a long term. It takes a long time to see any progress, and this one is so fun because it's like you said, from year to year, it is such a huge change and a difference. And I'm sure any of you who hike around the preserve or come by frequently have seen those changes, and so I love seeing all of that. We do have a couple of questions. I have a couple follow-up questions just about a few things. You were just talking about how the fish had switched from youth population, or from mostly adults to mostly youth. Is there like a reason that happens? What causes that with the BDAs? Do you know?
Yeah,
I guess.
So that's the scientific answer is I'm still working on it. I'm still analyzing.
Fair.
But the kind of just general guess I would give is that we changed the habitat pretty dramatically. So we took it from being more of a quick moving habitat to more completely dominated by ponding. And so juveniles of a lot of species really prefer super ponded habitats because it requires them almost zero energy to swim, so they can grow really quickly, while the adults tend to be more what's the word here, like territorial. They're more spatially limited, and so like having a bunch of adults, especially if it's ponded habitat, usually doesn't happen. The other thing is that for large bodied individuals, they need more oxygen. And so it could have just been an oxygen problem whereby they were kind of getting choked out and they needed to move to a different area of the stream because of that.
Awesome. And then another question that I had, and also someone else just posted, how do the BDAs lead to overall cooler water or stabilization of the water temperature? And then it says, I don't actually know that word, hyperetic groundwater connectivity when there typically isn't any. That's from Scott.
Hypereic, maybe. I can't actually see the question myself, so I'm just guessing.
Sweet.
Yeah, so
You got it right.
essentially what happens with beaver dams, right, is we pond up a bunch of water, and as the pond starts swelling, we're forcing water actually into the soil, into the floodplain surrounding the pond itself. So you reach this point where you're actually, if you store more water in your floodplain soils than you do in the pond itself, you have a larger volume of water that doesn't experience daily warming and cooling due to the sun. So you're actually stabilizing the overall signature of the water temperature by like storing a bunch of this water and preventing it from getting really heated or really cooled in the winter. And so instead of having mainly surface water signature of temperature, you're having groundwater signature. And so, as many of you might know, like if you want things to survive a long time, you store it in the ground, which is what the settlers did. And so that's like kind of the same theory here, is just dealing with the water itself.
Awesome. Thanks.
Thank you.
Ria, I'll let you ask the next one.
Another question we got from Nancy. Can you talk about the beaver dams on the Flying Dog Trail? Are they natural dams or did they start as BDAs? So this area, Marshall, I don't know if you've been there. It's pretty close to Swaner, up on the hillside. The Flying Dog Trail, really popular bike.
Yeah, it's the mountain biking trail, right?
Yeah.
I've been there. I've been there once. So I can't really comment on their history or their or their experience, but I'm pretty sure they're natural. I don't think anyone built them. They're in, beaver's preferred food, which is aspen. And the cool thing about aspen is it gets pretty large diameter really quickly. So beaver can build some really impressive dams with aspen that they just can't really build without it. And it's also the perfect size. Like it doesn't get like a cottonwood or a giant tree gets so big that a beaver can't move it. But most of the time, aspen don't get so big that a beaver can't chew it into little pieces and actually move it to utilize it as their dams. So not only do they prefer to eat it, but I think it's like probably the best, at least in the United States and North America, the best actually dam building material that's out there.
Yeah, I definitely think they're natural beaver dams, and they've been there since the construction of the trail, probably like 15 or so years ago. And that's an area you definitely have to slow down in sometimes because there'll be an aspen across the trail, especially in the fall when they're working on building up their food caches. I am going to share a link in the chat that I find really cool to look at, and it's a Bda Explorer Map. So it's kind of a map of a bunch of BDA projects all over the place, and just because they're not on there doesn't mean they don't exist, but it's kind of cool to see where all these BDA projects are. And there's definitely quite a few in Utah and mostly in the West.
Yeah, that dam is so interesting. I always stop there when I'm riding my bike past because you can really see like the fresh cut trees from the beavers, and there's always evidence of their activity around. We had one question from someone whose title is admin within their Zoom thing, and they were asking about how many of these BDAs are being installed close to houses, and have we had any pushback about them? That's a great question.
I can comment on where they're installed, but I'll let Ria talk maybe about the pushback or lack thereof. I'm not really sure. So we specifically chose sites to install these that were either very far away from houses in distance or in elevation. And so all the sites meet that criteria. They're either, the houses are either about 50 feet above the stream in elevation where flooding should never be a problem, or they're, hundreds of feet away from houses in distance and ground distance where kind of flooding or stream meandering, migrating shouldn't be a problem.
Definitely. That was definitely a key in design. And in particular, I think the BDAs that are behind the Blackhawk Station area are very visible to residents. And I've had some concerns from neighbors, and I think that's really tied mostly into just the past perception of beavers and them being a nuisance animal, and kind of shifting the narrative on that. And a lot of people are kind of realizing these ecological benefits that they can have. Most people who have had concerns I've talked to, and especially as they've seen the project over the years, we've had so many neighbors who are like, I've never seen so many birds in the spring, and sending us photos in all this new ponded water, which is just really cool to see. A lot of our neighbors are just our biggest advocates and greatest volunteers. So it's been pretty cool. And overall, we've had really, really great feedback and cooperation.
Definitely. It seems like people, just like even being at the front desk at the Eco Center, the more you talk about it and all of the amazing things that these beaver dams or beavers can do for an ecosystem, it's just beavers have gotten such a bad rap that we have to like educate to get the word out that they are important, which leads really well into Melissa Early's question about that with 100 BDAs taking place around the watershed this summer, how can we best tell the story of the wonder and importance of beavers for stream health to the general public or users on the East Canyon Creek trail zone?
Yeah,
That's a
Ria.
great question, Melissa. Thanks for joining. I think is a hard question, and we're definitely trying our best in a variety of avenues. We will talk about beavers for as long as you'll let us talk. All of our staff on any nature walks, or anytime you come into the Eco Center, send me an email. I know our whole staff in Marshall feel the same way. I really find like people seeing them in particular, and seeing those long-term benefits either in person or photos and video is really helpful.
We actually have, Melissa, I don't know if you've seen this, but we have a video. It's pretty short, it's under 10 minutes, where Marshall is explaining what he's doing in some layman's terms. And that we can share that. I'll share that in the resources as well, in case you like get friends who have questions and you want to share it with them. It talks a little bit about the importance. And then a book recommendation that I have is Eager by Ben Goldfarb, is an amazing book that is entertaining, and really explains why beavers are so important and how these restoration efforts can make a huge difference in us being able to help with climate change and affect our ecosystems in a positive way.
Let's see, another question.
I have a list if you want me to ask.
Yeah.
Unless you have it.
Really,
okay, so I'm gonna ask this one from Susan. She asked if any beavers have been brought in or relocated to this area to help with this project.
No, we haven't relocated any beavers, and the reason behind that, if I just scroll all the way back, I have a map here somewhere that kind of shows it pretty well. Oh yeah, this one. So there's actually 2 beaver colonies that are super close to this zone where we're building BDAs, and they're delineated by little beaver symbols. There's one down here that's it's about, I think in meters, it's about 400 meters, whatever that is in feet from our BDA complex. The closest one, and it's probably about a kilometer to the one that got colonized. And then there's another one up by the Temple Shalom slash Basin Rex Trail up here. And as I kind of mentioned before, it's really, really difficult to get beavers to stick in the particular location that you drop them off. They are quite exploratory little dudes, which maybe has led to their success and kind of prevalence across all of North America. So just because you put them in one place, even if you build them a starter BDA, doesn't necessarily mean that they're going to like it and actually stay there. So we're just kind of taking the if we build it, they will come strategy.
Awesome. And then a follow-up to that was for the BDAs that are being used by beavers in the East Canyon Creek area, what are they using for food and structure material?
Yeah, so the one that was taken over, I can show you that photo again. They're mainly using a pretty big stand of willows that are right there as food. So yeah, here's that photo. You can see on the left-hand side over there, there's a bunch of willows that are kind of died back because it's winter, so they don't have their vegetation, so it's not as clear. So they're using this really big stand of willows for food and building material. We have a couple cottonwoods in this area that are pretty rare on the preserve, so we've been really trying to keep them alive. They've been caged for I don't know how many years to prevent just passing beavers from chewing on them. But now that we have beavers setting up shop in the area, Ria has been painting trees with latex and sand so the beavers don't chew through them, because apparently beavers hate both latex and sand.
Fingers crossed on that one. A lot of paint that works if anybody's trying to keep beavers away from trees. Mixing exterior latex paint with sand, painting the tree like 4 feet tall, and then caging it, not super tight. That'll protect your tree, and we're hoping to keep those cottonwoods alive. Kind of along the same lines, this question from D, which kind of touches on the tenacity of willows. I think kind of in that artificially, I think maybe they're focusing this question to like that artificially straightened area where there aren't any willows. Willows seem like such a hardy plant that can kind of grow everywhere. In places like the rail trail, where there are some beaver dams, it seems like they just grow through the asphalt in some places. Could you maybe kind of talk about the tenacity of willows in beaver ecosystem, beaver dam complexes, and maybe why they weren't growing?
Totally, yeah. So willows are one of, after aspen, I think willows are one of the quintessential species that are kind of intertwined with beaver perfectly. The reason for that is really that when you cut a willow down, it typically doesn't die, it just sends up new sprouts. So it's almost like every cut you give to a willow makes it stronger in a hole. And so what happens typically with the beaver scenario is they go in, they mow down, this huge stand of willow, they eat a bunch of the sticks, and they kind of like beavers aren't very good at cleaning up after themselves. They kind of just leave their sticks around all willy-nilly. And so some of those sticks get washed down the stream and they get embedded in like a depositional environment, like a backwater or an eddy or something along the stream side. And they'll actually regrow from there, just from almost like asexual cloning, just being sent down as a willow pioneer. So that's one way that beaver can actually establish new stands of willow practically on accident. And then with the old stand that they've mowed down, the loss of the primary shoot actually chemically spurs willow to make new shoots. So you expect that after a willow gets mowed down by a beaver colony, it's gonna shoot back up within the next year or two. In regards to the lack of growth and the decrease of coverage, D, I think a lot of that was brought about by the lack of dynamics happening within the channels of East Canyon and Campbell Creek over the last 70 years or so. When the stream isn't migrating or moving, it's just set in one spot, there's less opportunity for new willow patches to emerge, either through landing of seed on like those bare mineral deposits like I was talking about earlier, or through that kind of like asexual just reproduction from a willow that's already been cut by a beaver by a person, because there's not a lot of places, you know, when a stream's incising and down cutting, there's not a lot of places for it to get established compared to when the stream is directly connected with its floodplain. You can have willows that get caught or stuck on the floodplain and get established that way.
Thank you. Stephen asked a question. Where did that go?
I just replied to it via text. Sorry, he just asked if we there's a need for volunteers to assist in building BDAs. So I'll let you answer that out loud as well, Ria.
Definitely will be. Like Marshall mentioned, we received a grant with Wild Utah Project to build 100 Beaver Dam analogs in the Park City, Snyderville Basin area. So that is we're gonna need a lot of help. And we would love to get you guys out there. It's such a fun project getting in the stream. Most of those projects take place in the summer and fall. So when the water level is a little bit lower, and we're going to be advertising super heavily for that on our social media and in our newsletter, and we'll be rolling out a new volunteer system for easy sign up as well. So if anybody's interested, you can contact me directly as well, and we can chat more about that. But we'd love to get you guys out there.
I'll also add to the follow-up email an option for signing up for our volunteer newsletter so that you'll get the updates about those projects when they come up. One other question, we have some questions about beaver dams in other areas around Park City, and I can, some of those I can ask about them. It's just they're asking about your familiarity with them, Marshall. One is about the beaver dams along the rail trail near Kearns Boulevard, which is where some beavers are relocated, I believe, last year. And then one question was about the beavers in the Silver Creek area next to the rail trail, which I think is probably the beavers that you showed in the first picture.
They're actually not. I know.
Okay.
I'm actually don't know where Kearns is, so I can't really say much to that. I know that the beaver along Silver Creek, along the rail trail, as you're headed out from Park City, have been there for a long time. And recently I learned that there's cutthroat trout that live in those beaver ponds too. So there's kind of a similar relationship going on where the cutties really seem to like the beaver ponds, and maybe gives them some separation from the brown trout and allows them to persist longer. But in terms of the beaver who is captured, I don't really, not too tuned in with that. Not sure what happened or why.
I'm not sure about that one either. Chris, for you, I do know that the beavers along Kearns on the rail trail were relocated by some of the staff at USU who are part of the beaver relocation project there. I think Nick Bowes is the person who worked on that.
And I believe that those beaver were relocated to the San Rafael Swell, I think, which is there's a BDA project going on down there, which is on the map that I shared in the chat a little bit ago. So that's where I believe those beavers went when they were relocated a little bit ago.
Awesome. I see that Sally has her, oh, sorry, go ahead. Keep going. Oh, no. I see that Sally has her hand raised. Mm-hmm. Sally, I'm going to allow you to talk if you have a question to ask.
Thank you. In the building of the rail trail in 1992, and when we came here in 1986, the rail trail was a channelized stream along the upper reaches of Silver Creek. And since that time, the beavers and the muskrats have built their homes there and have created an amazing wetland. I'm sorry that the beavers that get relocated from there don't come to you. I hear they must go to San Rafael. But are you working with state parks that owns the rail trail? And are you working with BLM that has an obligation to clean up the mine tailing site there? And how are the beavers impacting that? Thank you.
Yeah, so
Thanks, Allie.
I'm not working directly with the BLM or the state parks. I know beaver are surprisingly resistant to poor water quality. There's actually some crazy photos out there where beaver will actually dam up like effluent coming out of mines, so like the red and orange water that you see. And I mean, maybe they're mutant beaver by the end of it, but they seem to make do okay and not be too detrimentally affected by it. So I know they're fairly resistant to contamination. Actually, you know, kind of the process of sediment aggradation, sediment storage in beaver dams could be beneficial in ways from preventing contamination from actually going downstream. And if you cover, you know, contamination in enough material that it can't be broken down, it won't be biologically available or remobilized, hopefully, unless the beaver dams are blown out and there's another big down cutting event. But the rest, I unfortunately can't comment on. I'm limited in funding and time, so unfortunately, I can't work on all the beaver dams, although I'd love to. There's too many to study. I just had to pick kind of the most similar ones and the most nearby ones to the Swaner area, so that we could kind of do a comparison between our fake dams and real ones.
Thanks, Sally, for your question. I don't know if I have too much to expand on that. We at Swaner have been working with Beaver Dam Analogs only since about 2015 or so. And it's really gaining a lot of traction in the West. I know that US Fish and Wildlife is working over in the Richardson Flat area, doing some cleanup there and some restoration work. So maybe someday they would be interested in doing some Beaver Dam analogs over there once they could kind of see what's going on with the tailings. But thanks for your question.
I noticed that I missed a comment from Scott, and that was a question about have we been doing any supplemental riparian plantings in these areas?
Yeah, we have done a little bit, not as much as I would like, and I'd like to do some more on the preserve, and that's mostly just like a factor of time, and we're pretty busy in the summer. But there's been a lot of partners in the area working to do a lot more plantings in areas that have BDAs, and anecdotally, we see a lot higher success in places that have BDAs. So that's something we're really hoping to do too, and another project that will definitely need volunteer help for.
Yeah, and some of the complexes, like the East Canyon one in particular, that hasn't been colonized yet, has those historical plantings that were done, I don't know, maybe 8-10 years ago or something. So there's a bunch of little currants and willows and chokecherries and whatnot that are not the preferred food of beavers, so they haven't been hit quite yet, and they are also caged. So they're kind of benefiting from this elevated water table that we're creating.
Awesome. There's a couple of other questions. We're running close to time. I'll ask just two more. Is that okay with you guys?
Yeah, I can quick fire them.
Okay. One is about permits. This will be a quick one. I understand that the State Division of Water Resources requires a permit to install BDAs. Are we getting permits?
Yep, we have a permit. It's issued by the state and the Army Corps of Engineers. We got it for multiple years because we're running a multi-year project. So it's essentially a permit to like keep doing the same thing each year until the end of the project. Some places are starting to require temporary water rights. It's kind of dependent on downstream water users. They essentially open up the permit for public comment. And if no one comments with a complaint, then you move forward. So we were fortunate that no one commented with the complaint. So we moved forward.
Awesome. Can there be too many BDAs?
Yeah, I mean, I think there's definitely an argument that there could be too many BDAs. It depends on what your focus is for your restoration project. I think long term, I don't think there can be too many BDAs because these BDAs, these structures aren't expected to survive more than maybe maximum 10 years, probably median 2 to 3 years. So long term, I don't think you're going to cause damage by building too many BDAs because when they blow out, they're increasing the dynamicism of the stream. They're causing erosion and deposition in different areas and causing the stream to change. Short term, say you have endangered species or something like that, you could so drastically change the habitat in such a quick amount of time that you don't provide, for example, all the habitats needed to complete the life cycle of a fish or maybe something even less mobile like a mollusk or a plant or something like that. You could potentially over BDA it. Yeah. So it really just depends on your system and kind of what your restoration goals are.
Awesome. And then one more from Kelly. Are there examples of using Beaver Dam analogs in stormwater management?
So I think there's ongoing research about that. There's been some projects that look at similar like low-tech restoration structures, so like wood jams and rock steps and things like that look at non-point source pollution issues in the East Coast, particularly I think around the Chesapeake Bay watershed. And they've actually found that these rock structures and wood jams that create disturbances within the stream, encourage hyporheic flows, that is like exchanges with groundwater and surface water. They can reduce non-point source pollution. The Beaver Dam analog stuff is like still coming out. I mentioned that one study that just came out of Wyoming in 2020. So it's an ongoing process. I think the big problem with BDAs and stormwater, I personally don't find it to be that much of a problem, but I think a lot of cities are very apprehensive when it comes to beaver. I know the city of Salt Lake hates beaver, and anytime a beaver shows up pretty much anywhere in the city of Salt Lake, they immediately remove it because they're terrified of flooding, which is legitimate. And it's kind of where can we build these things that there's minimal risk of flooding plus maximum rewards in terms of bettering the stormwater that's coming out of various neighborhoods and development projects, etc.
Awesome. Well, thank you so much, Marshall, for joining us. Unfortunately, that's the end of the questions. There were a couple about other areas where there may be BDAs, and I can just touch base with you on those via email and send that in the follow-up. And maybe Ria's map that she linked, we can add into the follow-up as well that may help with those questions. Thank you, Marshall, for that awesome presentation and all the work you're doing on the preserve. If you do have a chance to volunteer or get involved with it, for those of you watching, it's definitely worthwhile. It's one of the most fun projects to participate in at Swaner, although they're all fun. So we'll send out information about that. Thank you, Michael, for partnering with us on this. And Ria, thank you for being here to answer all the conservation questions and for all of the hard work that you're doing for the preserve. Just so everyone who's still watching knows, I'll send you a follow-up email either later tonight or tomorrow morning. It will include a recording of this in case you want to go back. It will also include a survey. These surveys really help us in getting more funding for programs like this and in understanding how we're impacting our community and also in what programming we should do next. So we would super appreciate if you could fill that out. And then I'll also send any resources that we have, and then contact info in case you have any other questions.
Thanks, everybody.
Yeah, thank you for coming. Until next time, until next year's update, or until
Exactly.
next fall when we're rebuilding BDAs.
Yeah, when everyone can join in. Thank you so much, everyone. All right.
Hey,
Bye, guys.
can I ask no, I didn't want to jump in on everything. I really wish I would have explained the location